In our previous videos, we've learned a lot about how we can gather and control devices over Ethernet with either the Micrologix 1100 PLC or the Micrologix 1200 PLC. And specifically in this case, we are now able to control our PowerFlex 525 over Ethernet with our Micrologix PLC. And we were able to connect over I/O link to this encoder. So now we have an opportunity for a closed loop control system because the drive is controlling our three-phase fan. And as it rotates, we are getting encoder feedback over our I/O link back to the Micrologix. And this is a good example of a PID loop. So in our last video, we merged those two programs together. We left off, really, we have everything tested out and working. And we have a PID routine that is waiting on us to add something to it. So first of all, I'm going to go ahead and save what we have. And then we're going to go to communications, go offline. And let's go ahead and bring down a new rung. Oh gosh, let me do that a little better. And the first thing we're going to need is a new rung. Now we can go through all these tabs here, but also you can just right click and we can insert a rung. And then we're going to go to the file miscellaneous and bring down a PID instruction. And so the first thing we're going to need is we are going to need a PID file for this. And see, we're down to N15 with our program now, but let's right click data files, new. And we hit here, we want a PID. It knows we're going to be on 16 and we're going to click OK. And so that means that this will be PD16. And this is going to be what we're going to call this. We'll call this our motor speed loop. We have a process variable and we have a control variable. And we may or may not need to do some scaling on these, but honestly, this is about the way I see the people that come into my class start diving into PIDs. So the process variable is what are we reading? What is the thing that we want to achieve? And in our case, that is our encoder speed. Our control variable is how do you want to get it? That's going to be our motor speed. So over on our program, if we open up our PowerFlex, then through our messaging instructions, we were getting our motor speed. And in fact, I didn't put in this program. We are going to have to add that back, but we're going to go over here to N7. And right here, number 3 was our speed reference. And I forgot to paste all that part in. So this is going to be our speed command, not reference. That's our command. And then, yeah, I'm sorry. Oops, I left part of my program out, folks. Well, there's always a learning opportunity. So this is a good opportunity to review. So we had logic and commands message here, and that is writing to N7:1. And in that program, the main 2 bits I told you about that we would need in this video is if we go to the radix here of binary, N7:1, we need this one. This is our drive stop. We need this one. This is our drive start. That's the only 2 bits we're going to be using in this one. We're going to go back to our radix of decimal. And this one was our speed command. And it was 0 to 6,000 and 0 to 60 hertz. Now, we may need to do some scaling here in a second. But one, I want to go ahead and put those in just like we had them in the other program. You probably already have them in yours. I just don't. Honestly, I was moving on to another video when I realized we could learn about PIDs right now. And I was like, well, no, we need to go do that. So in that one, we had to go look for a 0, and it was for N7:1/1, which is our drive start. And we put an output energize of N7:1/0, which is our drive stop. And then we copy that rung and we paste it. Actually, no, let's just bring a new rung down. That'll be easier. And we're going to go look for a 1, go look for a 0. And this drive start tag, we're dragging right here, dragging right here. Because what that does is whenever the drives start, this goes false and puts a 0 here. This drive is not starting. This goes true, and that puts a 1 there. And then the last rung that I had in that previous video was over here on the Move Logical tab. We had a move instruction, and we had N7:3 go into N7:3. We weren't actually doing anything. We were just poking this out where you could see it. And we're actually going to review all this in a second. I can see already we need a quick review probably. And then we're going to go to the IO link, and mainly over here, we had our drive speed. So F84 has our speed in RPM. That's going to be 0 to 3600-ish RPM. And then over in our PowerFlex, our commanded speed, we hit to verify. Uh-oh, what did I do wrong? Oh, I'm not done with the PID. I know I'm not done with the PID. I just want to get this one rung in here. This one right here is going to be our commanded speed. So if I put 3000 in here, that is 30 hertz. Okay, so now we're going to look at our PID, and knowing that our process variable, or what we want to read, is going to be F8:4. That was the encoder speed in RPM, and it didn't like that, I don't believe. So we're going to hit the verify button in a second and figure out why. I get a feeling we need to do some scaling and get this into an integer, but I want us to see the error together. And this one right here is going to be N7:3. And then we did not get an angry error on that one. So first of all, I want to hit the verify button, and it's probably going to say wrong data type, invalid data type. So it's not going to like F84. So we're going to need to do some scaling. And this is very common with PIDs. And if we go in here, then yeah, we're going to need to work with a little bit of this, but we need to get that worked out first. So we're going to bring another new rung down. So we're going to go ahead and right click. We're going to insert a rung. And a cool way, if you don't know exactly where something is you can type the instruction. I'm going to type an SCP. That's a scale with parameters. And in this case, our input is F84. And then we're going to need the min and max of it, and then the min and max that we want to get out of it. Now, honestly, I'm not even sure the range of this yet. But so I'm going to put 0 for a minimum, and maximum, I believe, is 3600 RPM. But it doesn't really matter, because now my scaled minimum, I'm going to put 0, and I'm going to make this 3600. Because yeah, we're just going to do some really basic stuff anyway. So we're losing what we're doing here is we're losing our decimal. I could do a move here, but I want us to see that we could do some scaling here. So then we need somewhere to put this thing. Now be really careful. If we get the usage on this, you see that it looks like 5 and 6 are not used, but in the previous video, we talked about this. Is N7:4 is used in our PowerFlex messaging instruction right here, and has a length of 3. So that's N7:4, 5, and 6. 7 is the next one that is actually available. So we're going to double click on our PID routine, and we're going to make this N7:7. And we're going to call this our encoder scaled for PID. Now we may come back and change this scaling. I'm not sure if this is what this probably will get us what we want to learn about PIDs, but just in case, I'm going to leave it like that. And now I'm going to take that and I'm going to drop it right here. Now we're going to hit the verify button. So now it's happy with that, but it says error, first entry as symbol, PID 16 does not have an address assigned in the database. And we're going to hit the pause button, see it, because I have no clue what's going on. And, oh, well, they're 100% correct. I created PD16. I put PD16 here, but we need PD16:0 to get to our first number there. PD16:0. And oops, I didn't even need to do that. We'll take that back out. And now we'll hit the verify button. Okay, we have no errors. So we feel that we're probably ready to go with this PID. And honestly, this is where, yes, you feel you want to download right now. We're not nearly ready to, but that's what you feel. That's what we're going to do. Let's go ahead and download this. All right. Now, one thing right away is I can't see the value of N7:3 very easily. Whoop, and there we go. That's exactly what I was expecting to happen is we ended up faulting our PLC. And that's why I was like, they're getting ready to fault their PLC. We should go ahead and fault our PLC. Because really, we dropped it in. We had no errors. We felt like we were good. Now we're going to go to error. Do not hit that clear fault button. Let's go to error here. An invalid value is being used for a PID instruction parameter. Well, yeah, it's not a super intuitive thing, but the issue is we jumped the gun. Is the big thing that you have to have set is your loop update rate. Now, we should spend some time actually really learning about this loop update rate, but basically you have to think about how long does it take for your process to actually respond before you need to update this. Now, just to hit a few basics, is we know we have a sample rate on our IO link. The encoder update rate is 1 second here. And on our PowerFlex, we have an update rate of 1/10 of a second. So it doesn't do any good for us to go any faster than 1.1 seconds, really. So when I'm just arbitrarily, now we should put a lot more thought in this on our real processes. I'm going to put 2 right. Oops, we're going to put 200 right. Now the next thing is our time mode. So notice it's on STI by default. And so if we actually go over here on the, oops, I can't get there yet. Well, first we're going to change that to a timed mode. That's actually going to make that fire with that. And then we're going to click OK. So I can show you over here, we have function files. And you have a selectable time interrupt. So we could have put the PID in there and probably should have, but we stuck it in a regular program. And so we're going to use the timed version of this. Now, N7:3 still isn't doing anything. So if we go to data table, it's sitting there at 0. And this is where the frustration come in because one, we've got to get some values in these, but we also need to do a little bit of work over here first. So our inputs is arguably this 0 to 3600. So that means that we have a min and max here of 3600, 0 and 3600. And then our output is 0 really to 6000. Oops, that does not work. But notice that does not work. So we're going to be 0 to 100% here. And there's our current values. We have 0, we have 0. Now we have a set point of 0. So really, arguably, this thing's happy right now. So I'm going to make my set point 1000. Should be 1000 RPM. And now we see we do have an error, but nothing's happening here. So a few more things that we've got to do is, first of all, we have a control mode. Are we in auto or are we in manual? We are in auto. And at that point, we're to a proportional, integral, and derivative. Now, there are tons of myths out there on what these mean, and I'm not really going to get into that. There are some really good books out there on that, and there's some really cracked advice on the internet about that. But we're just going to put some values in just so we can see this thing start to move. So I literally am just way arbitrarily putting a 10 here, and we notice right away we get a 28 there. So this is our proportional control. And that is based on this error right here. Now, be really careful if somebody starts talking to you about future, past, and present. That is not what's going on here. We need to understand some math. But maybe we're not getting there. But right now, really, it's that this thing's not doing anything. We got 28 there. And if we go over here, that means that we're getting 4550 over here. Ooh, that doesn't look good for what we want to do. So first of all, we need to understand this output value. So we're going to go back into here. And now really need to know what the world is 100% here. We're going to switch this to manual. And we are going to put our output at 100%. And then if we go over here, that gives us 16,383. So that is our maximum value, 0 to 16,383. That's not going to work for us. So we're going to need to go offline. And we can do this online, but we're going to need to do another SCP instruction. So we're going to communications, go offline. And we got enough of it here that we're going to start with this. We're going to copy that. Now we're going to paste that here. Now, our output, we need a different tag for this one now. So if we go over here to our N7s, number 8 is the next available. So I'm actually going to put this on N7:8. And we're going to call that our PID output. And we just learned that its range is definitely 16,383 to 0. There's our min-max. And then our motor min-max is 0 to 6,000. Okay, now a couple other things while we're here. Oh no, this actually fixes it. We're going to be able to see, oh, I'm putting that in the wrong spot though. This needs to go to N7:3. Now we're going to be able to see our speed command while this is happening. And probably should build this manual auto out, but I don't think I'm going to go that far on this. And then we have our min and max here. That seems to work fine. And one last thing. I changed the control variable to N7:8 here, but I didn't actually change it here. We're still dealing with that encoder value. So we're going to drag that right there. And now let's go ahead and download that and see how it works. Program cannot be downloaded. Well, let's hit the verify button and find out why. Operand sizes do not match. Oh, I didn't think about that. The scale with parameters is a really cool instruction, but it is designed for either all floating points or all integers. So I have 16,383.0. Nope, we need the whole number, 16,383. Here we need a 0. Here we need a 0. And here we need just a 6,000. Hit our verify button. That fixes that. And we'll go ahead and download that. And okay, so we have a control output of 50 here. We're showing 3,000 or 30 hertz. We put it 100 here. That gets us to 6,000. Okay, now let's go back to auto. And when we do, notice that our control variable, it's now going to be set by the PID. That gets us back to this 28 number. Okay, good. We're trying to go 1,000. It's saying 3,600. Now, the issue right now is we are not telling our drive to run. So now what we're going to do is we're going to go ahead and go back to our PowerFlex routine. We're going to right-click that drive start, and we're going to toggle bit. That gets our drive running. Now we go over here, and okay, it says that we're running 200 RPM. We wanted 1,000 RPM. So we need to get some more out of this thing. Now, probably need to mess with this. No. So we're not getting nearly enough out of this to get it to the RPM that we want. And that's where all of a sudden the integral can come in. Now, we should have more than this in the proportional. We're just talking through some concepts here. But so this is what we call a steady state error. It, by this proportional math, it can't get where it needs. So now we wanted to do some adjustment. Now I'm arbitrarily throwing numbers. I'm going to throw a 5 here. And now, every 2 seconds, this is adjusting. So it's slowly bumping our speed up. And it's going to slowly get there. I probably should have been a little more aggressive with my proportional. In fact, let's do that. Let's go ahead and change that proportional to 5. All right, that got us a little speed there. Oh, no, it did not. It slowed us down. Let's make that 5. I put it at 0. All right, so that was way too much. So you need to hear the motor screaming at us now. Overshot. Now we're going way down. Now we're going way up. And that's what I see half of your PID is doing. Let's drop that to about 2. And then we're looking at this number now. XT, not oscillating horribly. Why did I put this at 1,000? I should have put it in a number that we didn't have to scream on the mic. So in fact, right now, I am going to drop this down to 500. So I'm not screaming at you. Okay, so you see it zigzagging a little bit now. It went down to 498, going up to 477. And so here's where now we really need a PID auto tune or a PID calculator to work us through these values. But what a lot of people will do is they will just kind of mess with these numbers until they get close. I'm going to go ahead and turn this off because I'm getting tired of screaming at you on the mic. I'm going to go back over here, toggle that bit off. So there's the basics of how to start a PID and how to control it. Now, I don't even know if I really want to go into a tuning video, but if enough of you comment that you really want to learn about tuning in the Micrologix, then I may go ahead and do it. But the last time I tried to do a tuning video on the Micrologix, everybody started saying, well, proportional is the past, integral is the present, and derivative is the future. And that's not true. It's math. But anyway, here's a playlist right here with some other helpful videos on both the Micrologix PLC and on PIDs.